Great, we're live.
All right. Well, hello everyone. Welcome to the second Hoot. And currently the focus of Hoot, this video series is about unboxing and getting to know service meshes. So if you followed along with us the last time, the Hoot series, we covered Istio with Christian, our field CTO. Today I'll be covering Linkerd. And in 2 weeks, we'll do another one of these unboxing Consul Connect. And so we're working our way through the meshes, and now we'll dig into Linkerd. As a brief background, I don't want to focus too much conceptually on what is a service mesh, but just to kind of ground the conversation, because I'll be using these phrases a lot. The service mesh kind of paradigm is how people are kind of deploying software now, especially with orchestrators like Kubernetes that make it really easy, where the paradigm calls for deploying a sidecar proxy next to each of your actual services. This enables you to decouple from your application some of the cross-cutting features related to routing and security, observability, and kind of expose the configuration of those features in a common user-friendly way. So that all of those proxies consist of the data plane, and then in the service mesh world, there's a control plane that is pushing the configuration to those proxies. So that is conceptually kind of what we're talking about here. And to start, let's go through a little bit like the focus of Linkerd, one of the kind of leading service mesh implementations. So this is the Linkerd website, and at the top, they give a really good summary of the focus of the Linkerd service mesh. And they call it the ultralight service mesh for Kubernetes. And specifically, it gives you observability, reliability, and security without requiring code changes. This is a pretty good kind of concise explanation of where Linkerd focuses, making it really usable out of the box. It's very simple to enable MTLS, start getting really interesting kind of tools to observe your application. That's really the focus of Linkerd, where if you kind of watched the Hoot video last week about Istio, there's a much broader kind of range of features, a much more complex configuration API, and there's trade-offs to that. There's advantages to using a mesh that provides those capabilities. There are advantages to using something focused on MTLS and observability, especially if that's your core use case. And in fact, just to, a good kind of background on Linkerd, if you're interested, there was a podcast with Will Morgan, who's leading the Buoyant on the Software Engineering Daily podcast, talking about kind of where Linkerd sits and really emphasizing that in the long run, there's going to be a lot of different mesh implementations, some that are really good for particular cloud providers. Maybe, Amazon, AWS has the app mesh implementation, and that might be the right choice for folks that are doing workloads exclusively in Amazon and in EKS. But that might not be the right choice if you're in a different cloud provider, or if you're specifically looking for features that are better suited by a different mesh. So it's an interesting angle, and I think as we go through the kind of onboarding for the product, we'll really see how they've been emphasizing these things over and over again from the jump. Now, before we dive into the kind of actual installation and demos, I want to talk a little bit about the architecture. So in particular, the question many people start with when it comes to gateways or service meshes is, what is the proxy implementation? So as we said before, we're going to be injecting the sidecar proxy next to every service in our application. In the case of Linkerd, they have an open source proxy that they've built alongside the control plane called Linkerd 2 proxy. I'll open that up. So this is an open source proxy implementation written in Rust. Linkerd essentially took the approach of, let's build our own proxy with the features that we care about built in. And they've been working on this for years. It's pretty mature at this point. There have been, dozens of contributors, 100 or more releases. It is worth noting though, because there are control plane implementations, for example, that are based on Envoy, an open source proxy pioneered by Lyft. So for example, Istio uses this. It has probably a larger feature kind of set surface area, but it requires kind of sending configuration in Envoy language. You know, there are kind of one advantage of going with something like Envoy as opposed to rolling your own is you can pick up improvements from the community. So for instance, Envoy community is really excited about WebAssembly as a way to further customize the behavior of the proxy. You obviously wouldn't get that with Linkerd, but you know, as we said before, that's not really the focus here. And for the use cases that Linkerd supports out of the box today, their proxy is more than sufficient, very performant, and pretty easy to use. Cool, and then obviously, so this is, if the data plane consists of all these proxy instances next to your application, then of course there's a control plane, a set of components that manages and sends configuration to those and powers the applications. So let's get installed, and then we can take a look at what actually those components consist of. So I'm switching over to my terminal. I just deployed Minikube, a fresh installation, so that we could start essentially from a blank slate. So the first thing that we'll do in terms of getting deployed is installing the command line tool. So one of the most common ways to interface with Linkerd, especially for the onboarding and the kind of initial install, is through this tool. It also serves, it's basically based on top of the same APIs that the web dashboard is based on. And so it provides in the command line really useful functionality in terms of tap and top and other features that we'll get into in a little bit. At Solo, we were really inspired by this kind of one-liner for easy install. So anyone can just run this single command, and it downloads a script, it runs the script, and make sure that you have the command line tool in the kind of expected location, prompts you to add it to your path, and then basically how to get fully up and running with Linkerd. Really like this kind of very simple, clear experience for the user. So I've already done this. I have Linkerd in my path. We'll do a quick version. Okay, so now I'm running the latest stable release, and I currently don't have the server or the control plane installed on my cluster. And in fact, if we look at the cluster, this is a vanilla Minikube. It was just installed 8 minutes ago, set up 8 minutes ago. Cool. So let's go ahead and do the first thing, which is a pre-check. This is really nice. It basically is a set of really quick checks, but fairly comprehensive, ensuring both that, or ensuring a bunch of things that make sure that you have Kubernetes running, you can query it, it's the right version. It checks out the RBAC of your Kubernetes profile or context, making sure that you can actually create the resources that need to be created, and making sure that there aren't conflicting resources that already exist. This is really great. It also kind of makes sure that your tooling is up to date. This is probably a good time to just mention as an aside, there are different release channels for Linkerd. So the latest stable release, which is kind of how they're intended for mass consumption and intended for enterprise users who are relying on long-term support. So the latest stable release was 2.6 or 2.6.1. It's the latest patch. And I read the announcement this morning. It looked like it took about 7 or 8 weeks since the last stable release. So they've been actually ramping up their velocity, and the releases are coming out once or twice a quarter. So let's do so we did the pre-check, everything looks good. So let's start the install process. Linkerd makes it pretty easy. I'm going to first run the install command, and as you can see, it spits out a bunch of YAML. This is basically a dry run. So what the install command does is produce to standard out all the YAML that you would need to apply with normal kubectl apply. We were kind of looking at the Linkerd code a while back, and one of the reasons that we did that this was kind of the recommended starting point as opposed to Helm, though more recently there is Helm support, is this manifest contains things like public keys, certificates that were generated during install. So this is kind of a good way to inspect a valid manifest for installing Linkerd. And now we'll pipe that to kubectl apply to actually perform the installation. So as you can see, it's kind of setting up the namespace and all of the RBAC for service accounts, roles, and role bindings. And then it's actually deploying to the namespace all the control plane components and configuration. Looks like everything got created. So just means Kubernetes resources applied successfully. Let's see what's in the namespace. So I deployed this to the kind of standard Linkerd system namespace. And as we can see, it's initializing, and let's run check. Now we're not running the pre-check, but we're running, we're kind of checking the active installation now. Again, a very useful tool as like a quick debugging step to see, are we healthy? Is there, and in this case, is the control plane healthy? Whereas before it was, is the control plane installable? There are also commands for checking, is the status of my application that's been injected with the proxies healthy? So these are really useful debugging commands. You don't really have to think about it. I can just run the command and feel confident if it succeeds that everything is good to go. Also, it's a good way to kind of, since the install command and applying that just kind of created the resources, it's a good way to feel confident that once check succeeds, actually the control plane is ready, not just in the process of being deployed. So the checks all passed. Now this means that Linkerd is healthy, good to go, and the control plane is installed. So let's go back to the architecture and kind of look at what is actually deployed here. So as you can see, we have nine pods here running. These are all the different components of the control plane. We can also look at these in the UI, but quickly I'm going to talk through kind of high level what the architecture is here. And actually, maybe it's useful to do this in context. They've got a really good architecture document. So here, this is the rough kind of architecture of all of the components. As we were talking about, there's a separation where the data plane is the application. This bottom arrow is kind of the requests path through the application. And as you can see, the requests go through the proxies, then to the application, and then they continue on. We'll talk a little bit, as we go through a demo, we'll talk kind of how that gets initialized, how that's set up in terms of what this pod configuration actually looks like. But first of all, in terms of the components, so there's two key components that help configure the behavior of the proxy in destination and identity. Destination is basically responsible for all the routing information, making sure the proxy kind of knows when a service or a URL is invoked, like how to find that resource. And then identity is a certificate authority that provides signed certificates to all of the proxy instances. That enables that seamless out of the box MTLS behavior between all of the applications that you've injected Linkerd into. So then there's a couple, there's a lot of other components on here. I guess the next question is, how does my application actually get deployed like this? Often when you're managing an application for Kubernetes, you're managing your own set of deployments, which tell you what pods will get spun up, what services to expose with DNS, what config to deploy, and secrets. But you don't want to have to go kind of manually augment all of that for the extra configuration so that there are proxy containers and the DNS tables and IP tables have been rewritten. So instead, there's a proxy injector component that helps with this process. And it can be invoked either dynamically through annotations on namespaces or generally like configuring configuring other resources in Kubernetes. It can be dynamically injected as those resources are applied, or it can be done as a command line tool, which I'll show in a little bit. Then there's several other features here. One is a service profile validator. So this enables you to add extra data on top of a service to say things like, here are the endpoints and the shapes of the requests and the responses to those endpoints. The proxy has a built-in support for a tap filter, so you can actually stream and watch real-time request and response traffic through a particular workload. There's a Prometheus and Grafana instance for metrics. It's set up to automatically scrape both the control plane API as well as all of the proxy instances. And there's a built-in dashboard that comes with Linkerd that has really good kind of starting point for monitoring the real-time health of your overall mesh. And finally, there's the actual API component, which is called controller, and then there's the CLI and the web, the dashboard that are built on top of that. So that's what all of these things are. Let me open up the dashboard and show you kind of what the control plane looks like from there. So this is pretty cool. It's kind of showing all of the, this is essentially showing the health of the control plane. So I can see it was successfully installed. Up here, there's kind of a recommendation for how to kind of get started. And then down here, we've got all of the actual components that I was mentioning in terms of what goes into the control plane, and then a summary kind of namespaces and whatnot. It's worth noting that all these control plane components are also meshed or injected with the sidecar. But obviously, they serve a different function than your actual application. Cool. Oh, and so the dashboard command essentially is setting up the right networking locally. So, in Kubernetes, that often means port forwarding, setting it up so that you're serving it through localhost. I'm running off of Minikube, so it kind of needs to set that up in the background. And now we also have this Grafana dashboard. So out of the box, I can already see kind of all of the traffic that's happening. Currently, this is just control plane traffic. So it's not super interesting, but we'll come back to this after we install an actual demo application. Just checking my notes. Okay, so I'm going to kill that. Now let's actually install a demo app. So first, we'll kind of, before applying it, I just want to take a look at what this is. So this is the standard Linkerd demo. It's called Emoji Voto. It's basically got several components. It's a web UI where you can select emojis as your favorite, and then you can see a leaderboard of who's been voting. It also comes with built-in kind of load tool so that there's active traffic happening, and it comes with some bugs so that you can kind of get a better sense of what it means to debug failing requests or broken services, which is kind of the purpose of deploying Linkerd in the first place. So it's quite a useful demo application to really understand the basics of the mesh. Notably, it doesn't have anything in this manifest related to the proxies or Linkerd. The word Linkerd isn't anywhere in here. So as I was saying, there is a component that helps with the injecting of that additional configuration, typically into your deployment specs, so that it's spinning up the right proxy container next to your real container for the application. Also, it's initializing the overall pod with the right certs and mounts and other things necessary for MTLS and to pick up the right configuration. But none of that's here. That's all done by the injector. And that's nice because a lot of people will manage this deployment in some kind of GitOps pipeline where it's not really into, you might want to not have to manage. You might want the transformation to be part of the continuous delivery part of the pipeline rather than actually kind of stored in your repo or however you're managing your kind of infrastructure config as code. So let's apply this. And now we've created a new namespace, so we can kind of take a look at that. We can look at the pods in that namespace. Now, it's worth noting, so far, I've just deployed the demo application. I haven't done anything related to connecting it with Linkerd. And as I was saying before, there's several common ways that meshes support kind of that injection or that onboarding of, or as Linkerd has called it, the meshing of pods or workloads in your application. So one of those is you could annotate, typically you can annotate namespaces or have some kind of global configuration with a mission control, like a mutating webhook or something to that effect. In our case here, we're just going to manually do it even after the application is deployed initially. But before we do that, let's just take a quick look at what this application is doing. So I'm going to port forward the web service, which is the actual site. This is the emoji application. Essentially, what it's allowing you to do is pick different emojis, and then there's a leaderboard. As you can see, by the time I logged in here, there's already been a ton of traffic. That's because of the load generator that's running in the background, and something like every second, it's putting a new vote in. It's also worth noting that there are some bugs in here, so we'll use the dashboard to start to drill into what those bugs are, but it's kind of built into the demo here. Cool. So now I've got my application deployed. It's running. Everything's going well. But I need to inject this with the sidecars to get it hooked up to Linkerd. In fact, before I do that, just to show, so if I look at kind of, need to be. So if I look, I can see that there is this namespace now. The UI, the Linkerd dashboard knows about it, knows that there's workloads there, but they aren't meshed. They're not injected. So you can't really do anything meaningful with those at this point with this dashboard. Let's go fix that. So the next step here is to actually, we're gonna do this a different way. Since the resources are already there, we're just going to read them out, run them through the injector, and then reapply them back to Kubernetes. So we can first do this. We'll do so first we'll get all of the deployments in the emoji voto namespace. Looks like so this is all of the actual deployments. Again, still this is just the manifest that we deployed before, so there's no Linkerd info yet. Oh, now I'll pipe that to Linkerd inject, and this essentially provides a dry run. So this isn't quite YAML because I'm seeing both standard error and standard out, but meaningfully, if I run the inject command but don't pipe that to kubectl apply, then it's just kind of spitting out to standard out what the manifests will be. And if we look through it, we can start to see how these deployments are actually going to be modified in order to become hooked up to Linkerd. Apologize for my scrolling, looking up to. Now we've reconfigured these, and let's look at what the deployments look like again. So now we can see some annotations here. We've got like annotations that we should be injecting these things. What I wanted to see, I'm not seeing it here. Let's look at what the shape of the deployments look like. So I'm running into a slight problem here. I'm not getting what I expect, which is essentially to have added several containers to emoji voto. So I'm going to go back to the docs and take a look at what I'm doing wrong exactly. So we kind of did the install, we did the pre-check, we installed Linkerd. Let's see what I was doing wrong. Oh, I was also, oh, never mind. I was looking at a slightly wrong thing. So now, so if I look at the pods, we can now see that there's 2 containers in each pod. And if we look at the actual pod spec, we can now see that, first of all, there's an init container in each of these pods. And the init container is running this container called proxy init. And this is basically setting up your IP tables so that the networking transparently to the application is now going through the proxy. So that's essentially has to be done as an init container so that by the time your application is deployed and the container is running, the networking is all predefined and set up to ensure there's, you're kind of communicating through the ports and with the MTLS configuration as intended. Then if we look at the containers on this thing, so first of all, there's one here which was already there. This is the same container that has always been part of this pod. And then we see a second container, and this was also injected. And so what this container basically is the Linkerd proxy with a bunch of environment variables and lost my mouse. Okay, a bunch of environment variables, and there's a certificate that gets mounted and some other volume mounts. And this is basically all the configuration necessary to run the proxy and to do things related to getting the right certificate and identity configuration. And as we can see, it's running the proxy container, the proxy image that we were looking at, the same version. Now, I was getting confused before because I was looking at the deployments looking for the sidecars, but obviously I found them in the pods. So the deployment has enough information so that when the pod is created, it is done so with the appropriate containers. Cool. So now we have an injected application. Let's go back to the dashboard and see how it looks now. So we can see this updated. The Emoji Voto application is now meshed, all 4 of the workloads that are running inside of it. This means that, it means that they are all connected to the mesh. They all have sidecars. We can look at that namespace and get kind of an overview of what's going on here. So we can see the 4 deployments. There's this funny kind of animation with a anti-gravity kind of. So over time, we can kind of see the request traffic, and in a more complex application, this might interestingly kind of rearrange over time as new services come online. And generally, can ultimately kind of get some high-level stats across all the workloads in the namespace, and we can drill in on specific ones to get a better sense. So let's first look at this emoji deployment. It's got a 100% success rate. So there's probably not anything interesting here, but we can at least get a sense of who's making requests to this workload. Looks like in this case, there's 2 common requests that the web component is sending it. This is a tap of all the actual live request traffic. So theoretically, we could let me go and report forward the voting app. So now we can continue to play around. The app's still running just as before, able to talk to it the same way. Theoretically, there should be more kind of traffic that's feeding into our actual dashboard. Now, if I go to the voting or and the actual votes are coming in here. So in the architecture of this demo application, the traffic, when I actually make a vote, it's actually coming here. Now, it's worth noting that every once in a while, these requests are failing. So I can already see here, whenever someone is making a request to vote donut, I'm getting a failure rate, and the success is actually 0% in this case. In fact, if we look, drill into, this gives another view of kind of, this is maybe a better view of the overall architecture of the application. So the bot is kind of initiating requests through the web to kind of emulate a user in the browser, and then the web is kind of making requests to the emoji backend as well as making actual votes. So we can see that the kind of when the bot is making a request to vote, occasionally that is failing, and certain votes, particularly for donuts, seem to be failing, whereas everything else seems to be pretty healthy. So right away, we can kind of get a sense of where the problems in this application lie. And that really, it kind of checks out intuitively from how we've been, our experience when playing around with the application. So we were kind of seeing, when you click there, we're getting a 404, but otherwise, things are pretty much working. And so, yeah, as we can see, and if we view the leaderboards, we can see basically everything's working fine. It appears that there's a problem with the vote donut endpoint that is always failing, and as a result, it also appears to be kind of causing some responses back to the bot to be failures. Cool. So that's kind of the extent of the demo that I wanted to go through, but I did want to touch on a few more really cool things about Linkerd that are worth mentioning without going too deep on for this intro session. So as I was saying before, like the focus of Linkerd is really on, first of all, rapid onboarding and ease of use. And as we can see, it was very quick to get things deployed. It was easy. There were a bunch of checks, so really good guardrails. And then once you've got once you've got the control plane deployed, there's several ways to actually go and kind of set up your application to be injected or meshed. And once you have that, you get all of these tools out of the box. And the key focus, or the kind of the best tooling that is really attractive to people with Linkerd are these tap and top capabilities. We were seeing it kind of geared around the deployments here, but you can really see both aggregate kind of stats about request and response rates, and generally the health of your pods or workloads, as well as the requests going through them. And then with the tap feature, you can actually look at these real-time requests. You can focus in on specific kind of source and destination, specific paths, and just do some interesting analysis on the traffic as it's flowing through your application in real time. And there's more information here if you want extra details about the requests. Currently, this is all that's exposed, but as you can see, it's already providing a lot of information out of the box. I'll mention here before leaving the UI that there's also this traffic split configuration option. Not going to go through a demo of this now just for time, but I think it's an experience that I've had working on service mesh stuff is seeing kind of Linkerd's presence as part of a broader community effort to standardize on the APIs for service meshes, which is called Service Mesh Interface, or SMI. So Linkerd was written to support all the SMI APIs out of the box. And one of those APIs is traffic split, enabling you to essentially reroute traffic for a particular destination to one or more alternative destinations. You could be using this for progressive delivery, things like Flagger, where you're essentially slowly shifting traffic over to a new version of a service, or you're kind of rolling out two versions of a service side by side to collect data from your users. So there's a really good UI for that here. And if you look at the most recent kind of release announcement, you'll see a lot more information about that. But the last thing I wanted to touch on is just really props to the Linkerd people for not just providing a good dashboard for this kind of information, but also good tooling from the command line. So if you, for all of these features that we were looking at, we can do the same thing from the command. So let's first get some stats. Or actually, let's first check. So we can do a check on the emoji Voto namespace and just instantly get a sense that everything's healthy connected to Linkerd. We can do a stat on the deployments and get some good aggregate stats. This is all Linkerd deploys Prometheus so that we can get and maintain these like relevant queries and aggregate stats. Oops. No. We can also get live stats. So we can do tops on the deployments in the namespace and see kind of real time what requests are occurring. And I've made this too large, it goes off the screen, but we can there's a lot more information off to the right if this was reasonably sized. So you got request count and there's some stats about the performance of those and so forth. And lastly, same thing with the tap. So let's tap a particular workload. So we'll do the web deployment. And here we get like actual access to the exact traffic. So where top might have been more of an aggregate per endpoint, this is now actually like a record of all of the inputs and outputs for a particular workload. So as you can see out of the box with basically zero configuration, we get really fast onboarding of a new service mesh implementation. Out of the box, we're getting MTLS for free with certificate authority that's generated unique certificates for each of our sidecars. And once we've onboarded an application, which is ultimately a single command, we're able to start utilizing all these interesting features related to observability, looking at aggregate stats about the namespace or about particular workloads, and then seeing the actual traffic. With Linkerd, you can also do things like configure policy. And as I mentioned before, they're starting to move into features like traffic splitting. So that about covers it for the kind of unboxing of Linkerd. There's a lot more things you can do once you've gotten through the basic getting started. So I would encourage you to really dig into the docs. It's a really good summary of kind of more broadly all the features that are available, and then some useful user guides to get an understanding of how to use those features, as well as other references. I mentioned the release channels, so there's the standard way that we installed is going to get us the latest stable release, but there's more frequent releases if you want to install the edge, so you can really stay up and running. And last thing I'll note is that there's a very active community, and a lot of enterprises are looking for essentially solving first with service mesh the things that Linkerd provides. And so the community around this is pretty broad, a lot of contributors and a lot of people in Slack. So if you want to learn more, I would encourage you to check these things out. Yeah, that about wraps it up. So hopefully you enjoyed this Hoot about Linkerd and now have a better sense of generally the architecture of Linkerd, what it looks like to onboard the control plane to your cluster, and then bring the data plane to your actual application, and then get a brief sense of some of the tools that are at your disposal. As I mentioned at the top, we're going to be doing more of these, kind of trying to hit all of the major service meshes and kind of be able to compare and contrast. So in 2 weeks, look for another one of these about Consul Connect. And yeah, I think I'm going to take a quick look to see if there are any questions. But otherwise, that wraps up the Hoot. Looks like there's nothing in the chat, so I'm going to end things here. In the future, if you are interested in kind of making this more interactive, would encourage you to follow along in our YouTube channel, where there's a live stream of this event, and you can actually provide questions, and we're happy to respond to those questions as we go. All right, thank you very much, and see you next time.